Hello everyone, welcome to the lecture. So in this lecture we will solve some problem from the week 5. Okay. So let's look at the questions. So this is our first question. We have given that 2 2p equals to q. So we have to find the value. Okay. So we have 4 power p by 2 power q plus 25 power q by 625 power p. Okay, so we can express 4 as 2 square, so it will be this. To p. Okay, so now we can write it as 2 power 2p minus q plus 25 power q minus 2p. So we have 2p equals to q, hence 2p minus q or q minus 2p will be equals to 0, right? So we can put the value over here and we will get 2 power 0 plus 25 power 0. So this is equals to 1 plus 1, which is nothing but 2. Okay, so the value of the given quantity is basically 2. Okay, so 2 is the answer. Okay, let's look at the next question. Question number 2. Half-life of an element is the time required for a half of a given sample of radioactive element to change to another element. The rate of change of concentration is calculated by the formula. So we have the formula where the gamma is the half-life of a material. A naught is the initial concentration of the radioactive element in the given sample, and AT is the concentration of the radioactive element in the sample after time t. Okay, so if the radium has a half life of 1600 years, that means we have given gamma, which is the half-life of material, is 1600. The value of gamma is given here, and the initial concentration of the radium in the sample was 100%. That means A naught is, the value of A naught is 100 here. Okay, then calculate the percentage of the radium in the sample after 2000 years. Okay, 2000 years. So T equals to 2000 here. Now we have to calculate the percentage of radium in the sample after 2000 years, which is according to formula, which is basically 100 into half to the power 2000 by 1600. Okay, now we can simply calculate it. Here is the calculation given. So this is basically, okay, so this is the calculation given here. This is basically approximately 42%. Okay, so this is our answer. So let's now solve the third question. So what's the question? Two functions f and g. These two are well-defined functions. So we have to find the domain of the composition function. Okay, so what is the domain of f? So what is the domain of f? Domain of f is basically x such that x plus 1 greater equals to 0, right? Because here we have the exponent as half. So we need this number as greater equals to 0. It will imply that x is greater equals to minus 1. That means minus 1 to infinity is the domain of f. Okay. And what is range of x? Range of f is clearly subset of a real number, right? And what is domain of g? Domain of g is the whole real number set, right? Because x square minus 1 is valid all over the real number. So clearly this is the domain of f and this is the range of f, which is subset of real number. That means domain of the function g. Hence domain of the composition function g compos x is equal to domain of f, which is nothing but minus 1 to infinity. Hence the third option is correct. Now, if we just closely observe the second option, it is nothing but minus 3 to infinity minus 3 comma 5 intersection minus 5 to minus 1. So this interval will be minus 3 to minus 1, right? So we will get this will be equal to minus 3 comma infinity minus 3 comma minus 1, which will be nothing but closed interval minus 1 to infinity. Okay, so this is just equals to the domain of the function f. So the second and third, both the options are correct answer. Okay, let's move to the next question. Uh, okay, so this is the fourth question. In a survey, the population growth in an area can be predicted according to the equation. Okay, so this is the equation. This equation will give the population growth in some area. Okay, where D is the percentage of rate of population per year and T is the times in initial population count alpha naught was taken. Okay, so if in 2015 the population of Adyar was this, so we can take 2015 as the initial count. Okay, so that means in 2015, that means when t equals to 0 in 2015, when t equals to 0, the alpha naught, the initial population was 30,000. Okay, so this is the value of alpha naught. The population growth rate is 4%. That means we have given the value of D, which is 4%. Okay, 4% per year. Then then what will be the approximate population of Adyar in 2025? 2020, sorry. So 2015 to 2020 means 5 years, right? 5 years. That means we have t equals to 5, d equals to 4, alpha naught equals to 1000. So we have to now calculate the value of alpha of 4, which is equals to 30,000 into 1 plus 4 over 100 power 5. Okay, so this is the quantity. You can now calculate this value. Okay, so yeah, here this the quantity is there, and this is basically approximately equals to 365 00. Okay, so this is our answer. Okay, let's look the next question. If fx equals to x square in the restricted domain, that means this is the domain of fx, then choose the points where the graph of the function f and f inverse intersect each other. Okay, so basically what is our first target here? At the first, basically we have to calculate what is f inverse. Okay, so we know that f compose f inverse equals to f inverse compose f is basically the identity function, right? So we will start with the equation. So if compose f inverse of x equals to identity of x means again x, right? So this is f of f inverse x, this is equals to x, and we have f of x equals to x squared. That means f inverse x equals to f of f inverse x means f inverse x power to the power square equals to x, right? So from here we will get f inverse x will be equals to root x. Okay, we are taking the positive sign because our domain is 0 to infinity and our codomain is also 0 to infinity. Okay, so let's now check what is f inverse comma f of x. So if we take x here, we will get f inverse of f of x. So what is f inverse of x? This is root over fx. Then we will get root over fx. And what is the value of fx? This is root over x square. This is basically x and it is equals to identity of x. Hence we got the function. We have fx equals to x and f inverse x equals to x, sorry, yeah, root x. Okay, now we have to find the point of intersection. Okay, so the point of intersection means basically we have to equate the function. That means at that point, the particular point will be in both the curve f and f inverse, right? So from here we will get x square equals to root over x. It will imply x power 4 minus x equals to 0. Okay, so we can take x as common, then we will get x cube minus 1 equals to 0. So from here we will get the roots as 0, 1, omega and omega square. So we know that omega and omega square are complex numbers, right? So these are not basically real roots. So only we have these two real roots which are 0 and 1. And what is f of 0? This is 0 and f of 1 is 1, right? So 0, 0 and 1, 1 are the correct option. That means these 2 points are point of intersection. That means these 2 points are common in both the curve. Okay. So here there is a written version of the problem. You can go through the written version for your better understanding. Okay, you can check this, and this is the graphical representation of fx and f inverse x. So we can see these are the 2 point of intersection, 0, 0 and 1, 1. Okay, thank you.